Hello, good afternoon. As Kyle introduced us at the beginning, I am Andrea Elvir. I am working with both Dr. Vasudha Sharma and Dr. Yuxin Miao. And I am a first-year PhD student and originally from Honduras. So today I will be talking to you a little bit about my research project and showing you a little bit of preliminary data of this project, which is influence of irrigation and nitrogen management on Cornmeal, water, and nitrogen use efficiency and nitrate leaching in Minnesota. So first, the environmental impact of irrigated agriculture on ground and surface water resources in Minnesota is a major concern, especially due to the soil types in the region, and appropriate management of both fertilization and irrigation is necessary to protect water quality and to do an efficient use of these resources. Especially here in the Corn Belt, where corn is the primary U.S. feed grain and row crop, and annually more than 36 million hectares are cultivated only with corn, only in the U.S. So many studies have been focusing on both irrigation or nitrogen management. And one of the major conclusions is that nitrogen and water are codependent factors and cannot be studied independently. And also that the crop water productivity will vary depending on the rates of nitrogen and the rates of irrigation. So that's why the interest in reducing irrigation to both preserve water and reduce nitrate leaching has been growing, and also adjusted to optimize the economic crop production. So the objectives of this project are to evaluate the variable rate irrigation and nitrogen rate application, and its effects on corn yield, nitrate leaching, crop evapotranspiration, crop water productivity, and water and nitrogen use efficiency. Also to develop the best management practices to optimize corn production and groundwater usage and minimize nitrate leaching. And finally, to develop personal and remote sensing-based, non-destructive in-season corn, water, and nitrogen diagnosis methods. So for this presentation, I will be mostly focusing on the first two objectives. So for this study, we will collect data for 3 growing seasons starting from 2020 to 2022. The farms or sites are located, one in Becker and the other one in Westport, Minnesota. Here, both sites are under coarse-textured soils. I know most of you have projects in those farms too, so we know the area. And most importantly, these are places with vulnerable water, groundwater areas. So we have a total of 24 treatments, in which are divided in 4 irrigation treatments consisting of 100% or full irrigation, which is everything that the crop needs. And then we have the reduced or restricted irrigation that is 75 or 50% after 100% irrigation, and then Rainpad. And then we have 6 nitrogen rates going from 0 to 292 kilograms of nitrogen per hectare for a total of 24 combinations. So you can see here the images of the corn with high water, high nitrogen, and the opposite, low water, low nitrogen, and its effects. So for this study, the experimental design consisted of a split plot designs with 4 replications in each of the sites, where irrigation is the main factor. For this, we use a GPS-guided variable rate irrigator, and we also use the nitrogen as a subplot. So there's me, there's the farm, this is the layout of the project. And as I mentioned, we use irrigation as the main factor. So what variables are we measuring? The first one, and one of the most important ones, is the nitrate leaching. So for this, we use suction cup lysimeters that are permanently installed in the ground at a depth of 1.2 meters to collect all the infiltration water below the root zone. And here we do we have allocated them groups. So we can sample in this axis that are in the LAAS. We can sample 6 lysimeters at a time or 6 plots. And we do weekly samples for about 5 to 6 months. Your big measurement is the soil moisture. For this, we use a nutrient probe moisture gauge. This takes soil moisture data from 0 to 1.2 meters in increments of 0.3 meters. We again do this weekly for estimated crop evapotranspiration and drainage, and also to schedule irrigation. You can see me doing the sampling in the field. For this, we have tubes that has been installed previously, and the gouge goes down, and then it measures the nutrient flux at every depth. Other measurements include plant samples at B8, R1, and R6, and soil samples, grain yield, and also proximal and remote sensing data, which I will talk to you a little bit about at the end. So now we get to some preliminary results, mostly from 2020. We're still processing 2021. But, well, first, I have here the corn yield versus irrigation. So you can see here, we have the seasonal irrigation in centimeters. So for this is the Becker side in 2020. Here we applied 17 centimeters of irrigation in the 100% irrigation treatments. And then we've got 75 and 50% of that for the R treatment. So you can see the corn in the y-axis, and we have all the levels of fertilization. So that's each of the lines. So here, mostly the higher nitrogen experience a greater increase with yield, with increasing irrigation water. And what was very interesting is that we obtained the higher yields here in Becker at the 75% irrigation treatments. However, there was not significant differences between irrigated treatments, meaning that we can reduce irrigation without having a major impact on the yield. Then we have 2021. So most of you have been here the last 2 years. So 2020 was a very rainy year, and now 2021 has been a very dry year. So you can see the contrasting effects of that, especially on the yield. So we go from the Rainpad one, which is the first red arrow, yield of 0 or 100 kilograms per hectare to the higher yields at the 100% irrigation. So this year, it's very exciting. We're seeing totally opposite results that what we got in 2020. We're still analyzing, but just wanted to show you a little bit what's going on. We applied almost double of the irrigation amount in 2021 for both sites. And here's a picture of how did it look at the Becker farm. So this is Rainpad at 0 kilograms of nitrogen, and then 100% at the highest nitrogen rate. So you can visually see the big differences in between the treatments, and of course we have all the in-between 23 combinations. Then here is the corn yield versus irrigation at the Westport side. So here, contrary to Becker, we observed the highest yield at the 100% irrigation and mostly at 314 kilograms per hectare. However, again, there was not significant differences in between irrigated treatments. Now we have the corn yield versus the fertilization, and we have one line for every irrigation treatment. So we here in Becker in 2020 observed the highest yield at the 314 kilograms per hectare of nitrogen with the 75% irrigation. And then we see Westport, where we obtained at the same nitrogen rate, but the highest yield were obtained at the 100% irrigation. And again, there were no significant difference in between the irrigation treatments, as you can observe. And now I wanted to show you 1,000 graphs slides. So this is just like a summary of what's happening with the nitrate leaching. This is Becker in the 2020. So we have in the y-axis the irrigation for each of the treatments. And then we have the months. As I mentioned, we do this approximately 5 to 6 months every week. So every dot will be a reading of every week. So and basically, you can observe that the highest leaching here in Becker was observed at the 25%, at the 75% irrigation, where we had approximately 25 kilograms of nitrogen leaching. So those are the red boxes, how much in average leached at this specific irrigation rate. And the red arrows are mostly highlighting the peaks in leaching, which are related to either fertilization or heavy rain events. So that's what those are. And then, well, here mostly we observe the highest leaching has to be expected in the higher nitrogen rates. However, as you see, it will vary depending on how much water are we applying to this specific treatment. So, for example, in the 75%, we didn't see the maximum leaching at the highest nitrogen rate. So that's what we want to understand and better adjust for the farmers. How much water am I applying? How much nitrogen do I have to apply if I reduce irrigation this much? So that's our main goal. And then we see Westport, where again it's a little bit contrasting. Here we have the highest nitrogen leaching at the 100% irrigation, but you see that this side received a lot less irrigation than Becker. This because it received a lot more rain. So so we see here very different results than in the Becker side. And mostly, again, to highlight that the higher leaching were at the highest nitrogen rates, as you can see. And again, the red arrows are the peaks of leaching where it increased mostly because of the fertilization. So here in both sides for this project, we do a split application of the nitrogen at B2 and B8 or 9. So you can see the both peaks around July and August that are closer to the fertilization of the plants. So in summary, under reduced irrigation rates, nitrogen fertilizer must be correspondingly adjusted. And then at the Becker side, both years, there was not significant differences between reduced irrigation and full irrigation treatments at any level of the nitrogen application. So this suggests that we can use this reduced irrigation without having greater impacts in the yield. And we just have to do a balance based on the economic optimum of the crop and the leaching or the environmental effects that this will have. And finally, the amount of rainfall received by the crop will significantly affect the interactions between nitrogen and irrigation, and therefore the yield and the nitrate leaching of every year. As you saw, comparing 2020 to 2021, we have extremely different results. So, well, the final part, we will need like 20 more minutes to explain this part, so I'm just gonna briefly mention it. We're collecting proximal and remote sensing data. We're doing dual X, which is very similar to spot meter. It's measured, in summary, chlorophyll, but a lot more than that. Then we're doing crop circumference. We collect the spectral data and thermal data, and also we're using the UAV cameras to collect multispectral and thermal images and Also satellite images, mostly for spectrum data. So that's pretty much it. Thank you, everyone. And let me know if you have questions. Yeah, so we base 100% based on the soil moisture at the different levels, and we also evapotranspiration of the. So we estimate the optimum irrigation amount for the crop every week based on the soil moisture data and the evapotranspiration.
So it's at 100%, is that your capacity is slightly less?
Yeah, slightly less because they're sandy soils, so we do a little bit more fractionate irrigation. So the optimal amount for this crop and for this type of soil and the conventional that you will put on it, and then we cut from that 75.
Like economic range that highest yield.
Yeah, we're doing that. I didn't show that data. Just too much to show, but yeah, we're doing optimal economic. For both things. Yeah, I read the next. You expect it to see high leaching, right? But you compare. Yeah, it's so we have the data for both sides here. So each line is a different nitrogen level, and every graph is of a different irrigation level. So we see significant differences as we increase the nitrogen. Usually is the higher leaching. So it will depend at every level of irrigation.
That's great, but then why is that? Why those won't come with
Well, what I understand of crop physiology is mostly that as we stress the crop, it will induce root growth and the crop to look further down for water. So it will develop like a bigger, stronger system, and it will help water use efficiency. What I think so far.
Same hybrid every time?
We have been using the same, I think, but I was not here last summer, so I don't have that on top of my mind, but I think it is the same. It's the same variety for both sides and both years. No, I don't think so. Just nothing special water related.